Let's find all the zeros of h of x. The highest exponent of h of x is 5. This is the degree of h of x. So since the degree is 5, it means that there are 5 zeros. And if we look at the sign changes, see the first term is positive. This whole thing is positive, so we'll write positive here. The second term is positive. The third term is positive. The next term is negative. The next term is negative. And the last term is positive. So now, from positive to positive, no change. Positive to positive, no change. Positive to negative, there's a change from positive to negative, so that's the first change. Negative to negative, no change. And negative to positive, that's another change. So there's a total of 2 sign changes. Okay, that means that out of the 5 zeros that we are going to look for, 2 of them are positive, and 3 should be negative. All right, so now we have an idea how many zeros we need to find and what kind they are, whether they're positive or negative. So this time we need to make a list of the possible zeros so that we can begin our search of the zeros. Okay, so let's list our possible zeros here. So possible rational zeros. Okay, and our list will include positive and negative of some numbers. Now, what are these numbers? So to determine that list, we need the constant term. So we need 8. So we need to factor 8. And the factors of 8 are 1, 2, 4, and 8. And we also need the factors of leading coefficient, which is hiding here, which is a 1. So the leading coefficient is 1. Factors of 1 is just 1. Okay, then we are going to divide the factors of 8 by the factors of 1. So we'll just have 1 over 1, 2 over 1, 4 over 1, 8 over 1, and that's going to give us 1, 2, 4, and 8. So we have a small list of possible rational zeros. So these 5 zeros must be in this list. All right, so let's begin the search. Now, if we notice there are 5 zeros, but there's only 4 different numbers in our list, so then it's possible that some zeros will repeat. Okay, so let's see what happens in our search. Now we're going to begin searching. So we take the coefficients. This is 1, so we'll put 1. Oh, I'm going to put the factored form there. So begin with 1, and then 4, and then 1, and then negative 10, negative 4, and then positive 8. As usual, we are going to try if 1 is a 0. So if 1 is a 0, we should get a 0 in the end. So let's use synthetic division. So we'll have 1, we bring it down, 1. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 1 plus 5 is 6. 6 times 1 is 6. Negative 10 plus 6 is negative 4. Negative 4 times 1 is negative 4. This is negative 8. Negative 8 times 1 is negative 8. And we found a 0 right away. So we found 1 0 out of the 5. So that means there's 4 more to find. So let's see. Is negative 1 gonna work? So let's find out. So we bring down the 1. 1 times negative 1 is negative 1. 5 minus 1 is 4. 4 times negative 1 is negative 4. 6 minus 4 is 2. 2 times negative 1 is negative 2. Negative 4 minus 2 is negative 6. Negative 6 times negative 1 is positive 6. And we're not going to get a 0. So this is negative 2, not a 0. Therefore, negative 1 is not a 0. Okay, so we're going to try negative 2. See if negative 2 works. So bring down 1. 1 times negative 2 is negative 2. 5 minus 2 is 3. 3 times negative 2 is negative 6. 6 minus 6 is 0. 0 times negative 2 is 0. This is negative 4. Negative 4 times negative 2 is positive 8. And we found another 0. So we have 2 zeros so far. Okay, so let's try if positive 2. We tried positive 2 already. So let's try forwards. So 1 times 4 is 4, 3 plus 4 is 7, 7 times 4 is 28, this is 28, 28 times 4 is a big number, 4 is not a 0. And I think 8 is not a 0. So at this point, maybe we should see if we can repeat the 0. So let's say, is 1 going to work? Is 1 a 0 again? Or is 1 going to be a 0 for the second time? So let's find out. So bring down 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. 0 plus 4 is 4. 4 times 1 is positive 4. And we found a 0. Okay, now we already have 2 positive zeros. So, and we need to look for 2 positive zeros. Therefore, the rest should be negative. So we are not going to try if 1 is going to show up one more time as a 0 because we already found 2 positives. Okay, so that means maybe we'll try negative 2, see if it's going to work. So negative 2. So we're going to have here, okay, bring down 1. 1 times negative 2 is negative 2. 4 minus 2 is 2. 2 times negative 2 is negative 4. And this gives us our next 0. So therefore, we have here, we have found 1, 2, 3, 4 zeros already. 1 0 left to find, and so we have here a linear factor. This is x plus 2. We can rewrite this, these are the coefficients of a linear factor. So x plus 2 equals 0. And so therefore, we'll have, if x plus 2 equals 0, we subtract 2 from both sides, and we're going to get x equals -2. So now we found all the zeros of h of x. So the zeros are, so maybe let's list it here, 1 twice, and -2 3 times. Okay, so twice and 3 times add up to 5 times. So even if there are only 2 different zeros, if we count the repetition, it's still, the number of zeros will still be the same as the degree of the polynomial. Okay, so now let's try to sketch the graph. So let's put the x-axis and the y-axis. Okay, so let's graph the zeros that we found. So zeros are 1 and -2. Okay, 1 and -2. Now, how about the y-intercept? So the y-intercept is equal to h of 0. So if this is 0, so 0, 0, 0, 0, 0, the y-intercept is 8. So therefore, this is 5. 2.5 is right here in the middle, so maybe this is where 8 is. Okay, so now how do we graph this? All right, so we know that from the y-intercept, we could go down here and touch the x-intercept at 1. But how many times do we have 1? Twice. Therefore, the graph should bounce here. So bounce at x equals 1. So that means when it gets to this, it's going to make a quick touch and go back up. Okay, then for this one, maybe it's gonna go up somewhere. Maybe it's gonna go up somewhere and then come down for this. However, -2 is a 0 3 times, so that means it's going to cross at x equals -2, and it's going to cross slowly. So maybe when it's like coming down, it may come down here, and as it approach, as it approaches this, it's gonna like kind of cross it slowly, cross the x-axis slowly at x equals -2. So this is how the graph should look like. So let's see, how does the graph look like? So here's h of x. Let's graph. And let's click on this. There it is. There's our graph.